Okay, YouTube, in this module of videos, we're going to be focusing on populations and samples as well as hypothesis testing when it comes to experimental data that we collect. And so let's go ahead and start by talking about what we mean by a population and a sample and how they're kind of similar and different at the same time. But we're just going to start with these three definitions that we see right here. Starting with population, we say that a population is basically the collection of all data. You notice I've underlined this here. By all data, I mean 100% of the data. And we could say these are things such as responses on a survey. If you had every response, that would be the population of responses, or any type of measurement or counts of objects that you want information about. Essentially, if you have all of the data, then we talk about it being the population. So you see on the right here, I kind of made this, I guess sketch here. You can see a screenshot of it, but inside my Venn diagram, you can see that the population is representative of every single object in this set of things that we're, studying. Whereas a sample, we just say, very simply, is just a subset of the population. You'll see that's the definition that I've got written over here. So we say that these are gathered by running experiments in a population and or just collecting data from the population. And so when it comes to collecting data from the population, I guess the first thing I want to confront here is this word census. And the idea of a census is something that consists of the data from an entire population. And so you may have heard this word before, at least if you're from the United States, okay? This word census, every 10 years we conduct a census. And in this effort, especially, I guess the federal government wants to collect data from all over the country concerning, I suppose, like age, income, geographic location, language, these type of things, okay? And so in order to get a better idea of its citizens, it does this census, but truly, is it really a census? I suppose you could see that a census consists of all data from a population. Do they really truly collect data from everybody? And so since a census, I guess, consists of all data in a population, you can see that that effort would not be, truly met in the official United States Census because you're not going to get data from everybody. So something I mentioned here is that unless the population you're studying is relatively small, for example, the people that are in the same room as you or the people that work in a specific doctor's office, say, then most times it's not feasible to gather census information from an entire population because you're just not going to get everybody's data. And so what we're going to basically focus on instead is just collecting data from a sample. And of course you would take a sample from an entire population and try to form an opinion about the population. And so let's go ahead and start by talking about this idea of a sample. We say that in most studies, information is gathered from a random sample. And of course, in the next, module of videos, we'll talk about different sampling methods. But a random sample, we say that it's important that samples we collect are representative of the entire population so that we can draw conclusions about the population based on the sample. So a couple things that I want to mention here. First of all, we want our sample to be good. That is to say, like if you were doing trying to make conclusions about the height of everybody in the population, male population in the United States, and you chose only NBA players, you're going to get a poor sample, and it's not going to be very representative of the entire population. But basically, the important use of statistics that we have here is to draw conclusions about the entire population based on the sample data. So we say that when the sample does not represent the population, the conclusions may not be valid. So statistics. Now, this is kind of the root of all evil here when we talk about all of these concepts of population sample. We're talking about statistics, but we say that it's statistics in general, this term. We mean the science of collecting, organizing, and interpreting data. But you'll notice that I put here, and absolutely underline this portion, a section where I say that an important use of statistics is to draw conclusions about a population. So basically, here's what we're going to write here. We have a goal. And basically, our end goal is to draw conclusions about the population. But see, the thing is, it's going to be hard to get all the population data. So to draw conclusions about the population based upon evidence from samples. And so really this idea of statistics is getting really good at saying, based on my samples, what can I say about everybody in the population? Say we're talking about people. So just a quick rundown on population versus sample. You'll notice that this example here says that we want to identify the population in the sample and then describe the sample. And so in letter A here, you'll notice it says in the US, a survey of 2,184 adults aged 18 and over found that 1,328 of them own at least one pet. So in terms of this here, we see this picture over here. It says population, responses of all adults 18 and over in the United States. And you see this little subset here. It says 2,184 of the responses responses of adults in the survey. So basically, when we talk about what's our sample and what's our population, looking over here, it's clear to us that the subset of the population that we're talking about is the sample of 2,184 people. And so when we refer to the sample, like what is the sample here, and describe it, we'd say it is a subset of all people 18 and over in the U.S. Okay, and U.S. Sorry, I'm not paying attention here. USA. Okay, so we say subset of all people 18 and over in the USA, because what they're doing is they're taking the survey of this many people here, this many adults age 18 and over. And so the fact that 1,328 of them own at least one pet, that's kind of thrown in there to tell you a little bit about these people. And so we could maybe make a general statement about the population. But as you look over here, you'll notice that the population is really the set of all adults, excuse me, 18 and over. And so we can see really the difference here is just that the sample is a subset of this population. So maybe in this next example, we look at the population first and then look at our subset, but it says to estimate the gasoline mileage of new cars sold in the U.S. A consumer advocacy group tests 845 new cars and finds that they have an average of 25.1 miles per gallon. So again, this would tell us something about this sample here, but in terms of the sample, what is it? We say the sample and the population. How about we start, we said, with the population this time. And so the population is the set of, I suppose, all new cars in the United States, or at least the gasoline mileages of all new cars in the United States. And so if I scroll down just a little bit here, give myself some room. It doesn't seem that I have any room, so we'll put it up here. Try to squeeze it in here. We say the gas mileage of all cars, and we better be clear here, new cars in the US. And so we would say that this sample here is just a subset, and I'll be clear on this one, subset of, it looks like 845, okay, new cars gas mileage. And so what we're really doing, again, is just taking a look at a sample of cars here, just a subset of the whole population of these cars. And so looking at this here, moving on rather, we're going to talk about the difference between a parameter and a statistic in terms of describing a population or a sample. So a parameter, let's start with this. A parameter is a numerical description of a population and is characteristic called a parameter here. Pardon me. It says a numerical description of a population is a characteristic called a parameter. And so basically what we're saying here is this. A parameter, this could be, for example, we'll write examples of parameters here. This could be the mean. This could be the median. This could be the mode. Okay, it could be any of these things. It could be the range. But when we look at a parameter, we're saying that are these things here that describe a population. So parameters, we're going to write a little key here. Parameters. Basically, you're going to associate this with the word population. And they describe, really, they describe a population. So basically, a mean, median, or mode, as long as you're talking about everybody, we'll just call it a parameter. Now, when it comes to a statistic, a little bit different here, a statistic, we say that is a numerical description of a sample is a characteristic called, a statistic here. So we say a statistic, interesting thing is this, mean, median, and mode, those are all statistics also, but only when they're describing a subset of, say, people or objects from the entire population. So a statistic, we're going to say here is this, I'll draw a little arrow here. Statistic goes with a sample. And so I always associate these together. If you want to associate any letters, we say parameters describe a population, statistics describe a sample. And so just to give you a kind of an idea of what the difference here is, we could say, looking at these two, I would basically want to distinguish between what are parameters and what are statistics. It says that for all students taking the SAT in a recent year, the mean mathematics score, the average mathematics score, was 514. So we say, is this mean score a parameter or a statistic? And we want to explain our reasoning. Well, looking at this, the fact is they told us that this was for all students taking the SAT. So that means that they have everybody here, and we're describing a population. So since this is the average of an entire population, we say that 514 is a parameter. And the reason why it is a parameter, well, because it describes the population. So it's describing everybody here, describes the population. Now with respect to this next example here, it says a survey of 1,060 women ages 20 to 29 in the US found that the standard deviation of their heights is about 2.6 inches. Their average spread is about, give or take, 2.6 inches. It says, is the standard deviation of the heights a parameter or statistic? And again, we want to explain our reasoning. It says that a survey of this many women. And so what we can conclude basically is they didn't say all women. And so since this was a sample of women from or a subset of women from the entire population, we're going to say that 2.6 inches is a statistic. And the reason why it is a statistic and not a parameter is because it describes a sample. Okay. And so what I want you to do here before you finish this video is pause this. I want you to try to get some conclusions for these 4 items here. And in 1 and 2, we want to identify the population of the sample. And when you're ready to go ahead and hit play on your video here. I'll go through the solutions with you. But number 1, just reading through this, it says to estimate the retail prices for 3 grades of gas sold in the U.S., the Energy Information Association calls 800 retail gasoline outlets and records the prices and then determines the average price for each grade. And so in terms of what's our population and what's our sample here, we're looking at retail prices. And so we could say, retail prices, if we were to label this in here, and this would be of what? Well, this is, I guess, gasoline outlets. So we'd say of all gas outlets. And so to describe the population here, we say the population is basically retail cost. And I'm going to say it in dollars here at all. And does it say average here? The retail prices, so we say the retail prices at all gas outlets. We're going to say this here. And I would say usually it's, like the average retail prices. But the sample, in this case here, it says, they call 800 retail gas outlets. And so the sample is this subset of 800 retail gas prices at those outlets there. So number 2, it said that a survey of 4,464 shoppers in the U.S. found that they spent an average of, $407.02 from Thursday through Sunday during a recent Thanksgiving holiday. So again, number 2, we talk about what is it that we're measuring here. And I suppose when we look at this here, we say, the average, cost from Thursday to Sunday during a recent Thanksgiving holiday. But basically, we could say, the average cost of tea giving for all consumers, or let's just put it this way, the cost of Thanksgiving for all consumers. And then we could say that down here, the subset here was these 4,464 shoppers from the entire population here that we picked on and got their data, but we'd say cost for those people. And so we could see that those are our population sample there. Number 3, basically, what we're going to do is it says a survey found that the median salary of 1,068 statisticians is about $72,800. Is this median salary a parameter or statistic? And they said that the median salary of this many statisticians. And so they did not say all statisticians. And so we would say that this is a statistic because it describes a sample. Whereas number 4 here, let's see if it is a population, see if it's different. The mean age of U.S. representatives at the start of the 113th Congress was about 57 years. Is the mean age a parameter statistic? Now, I would argue that because if we're only referring to the 113th Congress, then they got the age of everybody here. And so since they have the average of everybody in this 113th Congress, I would call this a parameter for the 113th Congress. If you were talking about just throughout history, then we could say it would just be a statistic because it would be a sample of the entire set of Congresses throughout history. So in this case, it would be a parameter for the 113th Congress. Cheers.